let's now go live. I just see participants. So it will be delayed by a few seconds.
Yeah.
So now again, you can also open YouTube. I see a bar of participants below.
Oh,
We
okay, that
want
is
to
something
remove
I
that.
also see. Let me see if I can remove that. Yeah.
If
So
I
how do I?
do layout changes on my screen, it don't affect anything.
Okay, how do I remove them? Let me see.
Can you do so in layout there is option full screen.
Switch audio, raise hand, dark theme, help checker, share, mute. Where is layout?
Yeah, so it is so you can see a bar of participants in on the top, right?
Yeah.
So on right of it there is a layout.
There's participants, there's chat, and then there's
You close that
polling.
chat. You close that chat.
Yeah. No, there's maybe let's see.
Yeah.
Raised hands. No, that's not the one.
No,
No, I
layout.
don't see any option, but maybe I can remove this somehow.
Can you, is there hide participants with okay, I'm hiding them. Then if I
Yeah, I don't know. See, because
so I did now, but if I change anything, it does not show up on video.
yeah, so I'm not seeing any option for disabling it in my thing.
In your can you show me this window?
Yeah, okay, let me do that. So how do I
See,
stop?
here is layout. No, but yeah.
I don't have that. Okay, let me just share my window now.
Okay.
Yeah. Okay, now I'm sharing the window,
Okay. So
and
different
there's
from
this bar here. So there's a participants thing here. Then there's a chat here, and then there's this, but that only has some polling.
okay. So if I
So
think, then does it change your window? If I have hidden all my participants stack side by side. So it's not changing your window at all.
yeah.
Okay. So if I keep full screen, let me play in full screen, maybe that will help.
Okay, and of course I'll then try to avoid that lower part of the screen. I think that's
Yeah,
the best
yeah,
we can do.
yes.
It's almost time to start, so let's just
Yeah. Okay.
do that.
Okay. So shall we start now?
Yeah, sure.
Okay. So welcome everyone to the lecture second. Now I hand over the session to Professor Amritanshu Prasad.
Okay, so hello everyone. I hope that yesterday's you had some time to think about all the problems in yesterday's lectures. I got some feedback that the problems I gave were relatively easy and most of you managed to solve them quite fast. Main thing, of course, was that you should learn to look at the documentation and self-learn. So today I will do some Python basics. So firstly, let's just learn a little bit about printing and input, which is helpful for many things. So the print command, you just say print, and you can type in whatever you like. Right? So that's the basic print command. It's very simple, and you can soup it up a little bit. So for example, so there's an input command. So you say input, and then the argument for the command is what is the string that you want on the input. So for example, I say input what is your name, and I could say name equals. So what will happen here is that it will ask what is your name, and then if I put in my name, then that will be stored in the variable called name. So now if you type the variable name, it says Amri. So now suppose I want to use this as part of some input, then I can say print, for example, I can say hello, and then I put braces, curly braces, and then I say dot format uh, name. Now, so what is going to happen is that this curly braces is going to be replaced by this variable name. So if I type now this, then it will say hello Amri. So there are many variations of this. So for example, if you want to be more explicit here, you can put uh, name here. Somebody needs to mute their audio. So you can put a more explicit thing here. For example, you could put username here, and you could say format username equal to name. It will work the same. Uh, so this is very useful when you have multiple inputs. So for example, I could have uh, so I could have something like last name, first name. So last name equals input. What is your last name? And first name equals input. What is your first name? And then I could say print hello, and then I could have, so here's one way of doing it. I could have two of these braces, and then I say format, and I give those two inputs. So I give first name last name. Oops. So if we do that, then what is your last name? I put Prasad. What is your first name? Amri. And then it says hello Amri Prasad. And you, if you want, you can put so suppose I want it in the reverse order. I can do this. I put numbers. Oops, that didn't work. So let's see. Maybe let me just try to remember what I need to do.
Index will be 0 and 1, not 1 and 2.
Oh yeah, 0 and 1. That's right, not 1. I forgot my own cardinal rule that Python starts counting with. And so it's now reversed the order in which those names appeared. And you could also use something like, you know, first, last, and then here you could put first equals first name, last equals last name, and it would work exactly the same. Yeah. So yeah, maybe I don't need to keep entering this, but anyway. So it works that way. So you have many options, and you can yeah. So you can just fool around with this, and so that's the basic print format. You can put you can even put first equals. Suppose I put a number here, then so it prints the number also. So it will convert it to a string and print it. So there's no issues with such things. Okay, so that's a basic print statement. We'll come back and look at slightly more fancy things in a minute. But let's move on to the next thing I want to talk about, which is functions. So one of the most useful constructions in Python is that of a function, or with any pretty much programming language. So you define a function by using a def thing, and then you give the name of the function. So for example, let me create this function called double. Okay, now Python is dynamically typed in the sense I don't need to specify what the output of this, what is the data type of the output of this function, or what is the data type of the input of this function. You just go ahead and start defining the function. So what is it saying? I'm going to define a function called double, and it is going to take the input x. Now it is a good practice for all Python functions to have at least one line what is called doc string. So it's usually an instruction to the program, but yours actually it's a good practice when you're developing something more serious to have detailed doc strings. But you know, I'm not going to go into that much. If you want to see more about these detailed doc strings, there are these Python enhancement proposals you'll find online, and you'll find I think there's one called uh, PEP 257. So let me just so let's just so there's this PEP 257. It's a guideline for how Python doc strings should be written, and you want to write, especially if you're doing something you're creating something that is you're going to be working on for some time and others are going to look at. You must always put minimally one line doc string, but you have the option of putting in more doc strings. In doc strings you can also do testing, and it's quite so. For Sage itself, it has its own system of doc strings. You can look at the Sage developer guide, which is even more elaborate than that of Python, but that becomes mandatory when you're trying to develop for Sage. But here, let's just keep this practice of putting in one line doc strings. I'll show you another advantage of doc strings in a moment. And then a function must have a return statement usually, not always, but usually it should have a return statement which will give you the output of the function. If it doesn't have a return statement, then it will return a null type, which is called none. But here, let's just say return 2 into x, or maybe we could say return x plus x. How about this? So that's the double of x. Okay, so now this is a very simple function and I have defined it. So now let's look at this. So if I say double and I put question mark, then you will see at the bottom of the screen this doc string information shows up, return the double of x. So what you've done is, along with the function that you've created, you've also created the help for that function. So you can put in more details about what x is expected to be. So now here, there's no, I can try to run this. I could try to run double of 5. We expect it to be 10, and indeed it is 10. But we could also do double of Amri, and it says Amri Amri. So this is different from JavaScript or C++, because we have not specified the variable, what kind of variable is in the input. But what Python does is, whatever you give it, it tries it out, and then if it works, it works. So there seems to be some sort of plus for two strings, which concatenates those strings, and so here it has done that. So this could be this gives you great flexibility. You just have to write one kind of code which may work on many different kinds of inputs. But on the other hand, it can also lead to confusion sometimes. Uh, uh, so it's always good to say in the doc string what x should be. Okay, so take a look at doc string details and so on. It's fairly important to have a doc string for functions. So I would encourage you to just put in at least a one-line doc string, if not more. So that's your basic uh, function. Now you can have functions with more than one input. So def sum of x comma y, uh, So now there will be two inputs, and let's say return the sum of x and y. And so what would I do here? I would just say return x plus y. And now if I type sum of 2 comma 3, it will say 5. And if I type sum of Amri and so that's a string, and then I put in another string. Let's put a space here, and let's put another string. Then it will add those strings. So you see the same kind of behavior. And there is default values which you can pass. So suppose I say sum of x comma y equals 0. Then if I type, of course, so this will not affect the behavior here. If I say sum of 2 comma 3, it will still give 5. But if I just say sum of 2, it will assume that y is 0 and give 2 only. So this is useful when you are trying to, create variables where you have optional, you have functions where you have optional inputs for which there are default values. Okay, so I hope it's clear what the basic structure of a function is. It has a def, and everything within the scope of the function is indented 4 spaces, including the docstring. And once you're finished with your function, you can come back to unindent 4 spaces. So this is outside the function. So now I'll also add something which is inside the function to show you. This is inside. So now if I do this, okay, it did not. Okay, it did not print that, but it printed this is outside the function. So things which are oh, that's because it's after the return. Obviously, it's not going to print it. Once the function returns, it's done. There's nothing more. Yeah. So this is printed only when the function is run. Here the function is just defined, so this is inside is not printed, but this is outside the function is printed because it's outside the function. It's like a new line of code here. But the function was not called here. In this, the function is called, so whatever happened inside the function is printed and not what is outside the function. So the scope of the function is just given by the scope of your indentation. Let me just illustrate one more thing here. The data types can be different sometimes, and it might even work. So suppose I do sum Amri and 3, number 3. I think it's not really working. Let's look at what the error message says. So there's something about coercion model and so on. But finally it says type error, unsupported operand parents for plus. So you cannot do a plus between a string and an integer. But sometimes you can do two different data types. Suppose instead of Amri, I put 2.15. So now this second argument is going to be an integer, and the first one is going to be a floating point number. But this works, and that's because Python has something called a coercion, which tries to, when it gets two inputs to a function, or when it gets an input to a function which is not what it expects, it tries to see if there is some way to make it, turn it into something that is acceptable to the function. And this is called a coercion model. So that's at work over here. And what it has done is it has coerced this 3 into floating point. It cannot do the other way around, but it has turned this 3 into a floating point. Okay, but there is a way to turn a floating point into an integer, but of course it will involve rounding. So there's int 2.15. And Sage has another thing called integer. So that's a bit different. Oh, that's not working. Okay. But Sage has a data point type called integer. So that's there's some confusion here because sometimes Sage automatically assumes that what you're typing is a Sage integer and not this is a Python int. So yeah, you may run into these kinds of issues when you're debugging your code.
So
Okay,
what is
so
What
Yeah,
is that model portion? How can you type it? I'm not getting the spelling. I want to understand.
coercion. It's called coercion. So let me just type it up. Where am I? So uh, so Python uses coerce.
Okay.
It's like when you force somebody to do something. I hope I got the spelling right. Maybe there should be an S here, no? Yeah. It's the same word in English when you're forced to do something, right? I was coerced into doing something. So it's called coercion. Um, and these are related to classes and so on, which I'll come to tomorrow. Um, it won't bother you. Python will take Sage or Python will usually guess what you want to do. And oh god, so many spelling mistakes here. Coercion. What is the spelling of coercion? Anyway, it doesn't look right.
This cell is different from the usual cell. Now you're using it to show the text, right? This Python
Yeah,
uses
so this
Coercion.
is a markdown cell. So when you look at this cell, edit, uh, yeah, uh, insert cell, let's see, cell type. So there are two kinds of cells. There's code cells and markdown cells. So code cells you run code, markdown cells you type in markdown,
Okay.
and you can get all kinds of formatting links. So here is, for example, markdown for a link. So you put the text in square brackets followed by the URL in round brackets. Uh, so yeah, so you can use. In fact, once you have this uh, what do you call it? This worksheet, Jupyter worksheet, you can export it to HTML. So the code cells will not work, but they'll all be displayed nicely.
Right.
And yeah, so I think there is save as, download as, and you can download as HTML, for example,
Mm-hmm.
and you can also download as Markdown, I guess. Yeah. And PDF. So you can if you want to demonstrate something or help somebody to you've written some code related to your research paper, and you want to explain to people how to use it, it would be a good idea to create a worksheet where you demonstrate the use of this code, and then you just uh, export it to HTML so that people can see it. But of course, it would be a better idea to also have a link to the Python notebook so that people can download it and use it as well. Because the HTML thing cannot be used, the code cannot be run, it can only be looked at. So,
You use
but
some keyboard shortcut, right?
I was using keyboard shortcuts. Yeah, so those shortcuts are all in the help,
Okay. Okay.
keyboard shortcuts.
Okay. 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 Thank
Okay, so I think Y is for code and M is for markdown. So this you have to escape. M it becomes markdown. Y it becomes code.
you. Okay. 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 Thank you.
And then A is to insert a cell above. B is to insert a cell below. There's
Okay.
ways to merge cells, split cells, whatever you
Okay.
want to do.
It's very handy.
Yeah, so it speeds up things. I only remember a few of them. Okay, so
Okay.
that's so much for basic functions. Now let's go to, so before we talk about loops in Python, we must talk about at least about lists and more generally about iterables. So let's start by talking about lists. Uh, so So these two hashes in Markdown means a second sort of subheading. So this is the first one hash. This is two hash. So lists in Python. So basic idea of a list is, as I told you already last time we saw these. You take square brackets and put a bunch of things inside it. So I could put uh, one, hello, and maybe 3.3 by 2. Let's see. So there's no restriction on what the different things inside a list are, they can all be they can be different. Some can be strings, some can be integers. This 3 by 2 is not a Python thing, it's a Sage thing. It's a rational number. To find out what something is, you can type. So it says type is, it's a Sage rings rational, rational. So it's a rational number, it's a Sage thing. Now, if you're using Python, this would be evaluated to 1 or something, because it's trying to divide them as integers. Okay, so here's your list, and you can access elements of the list. For example, L0 would give you the first element of the list, L1 would give you the second element of the list, and L2 would give you the third element of the list. There's also a way to access from the end. So L minus 1 will give you the last element of the list. L minus 2 will give you the second last element of the list, and so on. I'll share with you a worksheet where all these things are explained in detail after this lecture. And if you give some index which is not there, so here I can give L minus 1, minus 2, minus 3, minus 1, this is minus 2, this is minus 3. But if I give minus 4, it will give me something called an index error. So it says list index out of range. So this is a list, and it's your most basic example of what is called an iterable in Python. An iterable is something you can iterate over, and if you want the technical definition, an iterable is something for which you can talk about iter. So if you type iter of L, it gives you something. Okay, so I will come back to that later. But let's talk about some basic ways. So suppose I want to create a list of integers from 1 to 10. I don't have to type in all of them. I'll type range 1 to 11. So, okay, this is not very helpful. When I type it, it just says range 1 to 11. It doesn't tell me what is in this thing. So what you can do is you can convert it to a list. So this range 1 to 11 is not a list a priori. It is an iterable. But when you try to evaluate it, it gives you this list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is happening here? The first number is this 1. The second number is the second, the last number is not the second argument, but when you reach the second argument, it stops. So the last thing less than the second argument. So this is the range. This is the range, and so what is happening here when I just type range, it doesn't evaluate it. And this is because you can, okay, so there are 3 kinds of ranges. So you can just give range with one number. So if I do this, it will give me, it will assume that we start at 0 and we end at just before 10. If I give 2 things, it will, this, so I could give, for example, 5 to 11. It would start at 5 and end just before 11. And I can also do 3 things, which will tell how much to skip by. So I could do 1, 20, and 3. Now what it will give is, it will start with 1, then it will give 4, then it will give 7, and it will stop when you hit 20 or you cross 20. So there are 3 inputs for range, but you can give only one, 2 of them are optional. So if you give one input, then it's going to just take the, it's going to start at 0 and end with when it before it hits that last number. If you give 2 inputs, it starts with the first one and ends with before it hits the last number. And if you give 3 inputs, it also gives you the skipping. So this is the range, and this is used to generate lists of integers which are in arithmetic progression. So we could call these arithmetic progressions as mathematicians. But what is happening when you don't type list is it is being lazy. So when I type this, it is not going to actually evaluate all the things in this list. It is just going to say, okay, this is a list, I have created it. When needed, I will find out what is in it. And this is very useful. It gives you efficiency. suppose you're going to do, suppose you have to calculate a large number of cases over some iterable which is very complicated, then you don't want to store all the things in that iterable. You just want to get them one by one and use them, and then move on to the next one after you have used up one. So that's that's the principle behind iterables. A list is an iterable which is already sort of all the things are stored in it. Another similar iterable is called a tuple. So I can also so I have this list. Let's just copy this, and I can also make it a tuple. It looks pretty much the same. So let's just. So firstly, I have this list, and now I'll construct a tuple. The only difference between lists and tuples when you're creating them is that lists have square brackets and tuples have round brackets. So if I print L, it'll print it. If I print T, it'll print it. So both look very similar, and I can convert a list to a tuple and a tuple to a list. So if I say list T, it becomes a thing, and if I say tuple L, it gives it. Okay, but what is the difference between these two things? So a list is mutable. You can change. So lists are mutable. You can, once you've created a list, you can change one element of the list. So I can now change L1. So L1 was hello. I can change it to goodbye or goodbye or whatever I like. So, and now if you type L, you can see that hello has changed to goodbye. But if I try to do this with the tuple, then I get a type error. It says tuple object does not support item assignment. So once you create a tuple, it is fixed once and for all. So you may ask, why do we have these two different things? Well, if you think about it, tuple is cheaper to create uh, because you don't give it the flexibility of changing the entries, whereas a list is a little more expensive. And so if you know for sure that the iterable you're creating is not going to be changed or expanded in any form or so on, then you should use a tuple. Otherwise, you should use a list. Don't worry about it too much. For most simple programs, it doesn't matter, and it's just convenient to use lists because it doesn't usually make such a big difference. Um, but you can use tuples or lists. But both of them are they are different from this range, for example, in the sense that when you create them, they already have all their elements listed out. Each element is stored in the memory. Whereas when you create this range, the elements in this range are not stored in memory. So you can have, this. It has not stored 10,000 things in the memory. It has just created this range. And when you start your program, when you start going through this range, you will be able to. I'll explain to you how you start going through a range without expanding the list in a bit, and then we'll see how to create our own iterables tomorrow, I think. So, okay, so let's see. So tuples versus lists. That's done. One thing which I found a bit confusing when I started off is how do you create a tuple with one element? So if I say T is just this tuple, say consisting of the letter A, then it doesn't actually create a tuple. It just creates letter A. So this parentheses are ignored. So what you need to do is to put a comma after that, and then you get a tuple with length 1. This you can try to see compare tuples and lists by saying t dot tab. So this will show all the methods that are available to tuples. And tuples have only two methods, count and index. So this count will tell you how many times something occurs in it. So t count a will give me 1 because a occurs once in this tuple. But if I had t equals a comma 1 comma a, and then it shows 2. And the other one was t dot index. And now if I type t dot index A, it gives me the first occurrence, the position of the first occurrence of A. So tuples have only 2 methods, count and index, but lists have a few more methods. And do I have my list? Oh, L is, what's going on here? Yeah, okay, I have my list. Okay, so now if you look at list, it has many methods, and it has a method called append. It has a method called clear. So many of these methods, it has insert, pop, remove, reverse, and so on. So many of these methods are there because it is mutable. If you couldn't change it, then it would. So I can use, for example, to say f.append 4, and then I look at what has happened to, so it doesn't give any output. So what it's doing is, this is a method, it's modifying the list in place. And so if I say, now if I look at L, oops, now if I look at L, you would see that it has added a 4 to the end. A common mistake is that someone might say m equals L dot append 4. You would expect that M has got this new list with it, but M is actually nothing, because L has changed, but nothing has come out of this method. So this is a function which doesn't return anything. It just transforms L itself. So this modifies L in place. L is still modified. One more 4 has been added to the end of it. So this is the append method. You can explore the other methods. Um, you can explore the other methods. Uh, there's reverse, fairly self-explanatory. There's pop. So one nice thing, or one thing to, well, maybe helpful to know about lists, especially when you're trying to write programs that run fast, is that a list is implemented as a stack. So it's very easy to remove things from the end of a list. It's very fast to add things to lists using append, and to remove things from the end of the list. But it's not so easy to remove things from the middle of a list or from the beginning of a list. So when you're designing your programs, you should try to, as far as possible, use lists as stacks. Though it has all the functionality, but if you want things to happen really fast. If you're getting into all this, there are data structures called DQs where you can remove from the beginning and the end. So, but that's all, like, maybe not so important when you're starting off. So okay, so let's see, what else did I want to talk about? Okay, maybe I'll stop now and just see if you have any questions. So are there any questions? Oh, I haven't opened the YouTube window. Dilpreet, can you just tell me if there are any questions on the YouTube window? Maybe I should try to open the YouTube.
So in YouTube, we have only one question. Sushma Rani is asking that, does the input function works?
What do you mean, does it work? Of course it works.
Yeah.
Yeah, I showed you how it works. So
Okay.
yeah, are you having trouble using the input function, Sushma Rani? Is there some issue here? Maybe let me try to open the YouTube.
Irfan Habib is asking that, how to access elements in tuple. Is it similar to that of lists?
Yeah, so if you want to get something out of a tuple, you can use the same kind of thing as in lists. Oh, okay. By the way, that's good. That's a good question, because I also wanted to say something about slicing lists. So I'm just opening the YouTube thing so that I'll have that also. Okay, so that I can see the, yeah, okay, it's here. See the questions on YouTube. Okay, so yeah, so one more thing, good, thanks for reminding me. So let's look at, so let's create a long list. So I have this L equals some say range 100, and let's make it a list. So maybe I don't need to do that. And if you type it up, it gives you all the 0 to 99, all these numbers. But now I can also take this list and I suppose I want the first 10 entries, that I'll say colon. Maybe I want entries from 3 to 7. Then it gives me 3, 4, 5, 6. So I can do, and just like with the range, I can give a jump also. So I could ask for 3 to 70 with jumps of 9. So it will give me the elements of the list starting with the fourth element, which is index 3, going up to the 70th element, which will have index 69 in jumps of 9. So you can do the slicing of lists. Now it's a bit silly to do it with range, but maybe I could start with the reverse of this range maybe. So there's a fun thing you can do with ranges. You can put a negative. So I can start with 99. I can go down to 0, and I can put a step of -1. And this works too. Okay, so you can also have ranges which run backwards, and it can make it more complicated here. Okay, so I put a -2 there. So you can do this with lists. You can do all this with tuples also. So t equals, let's say, tuple, and I will do the same kind of thing, range. Well, let's just change it up here. Okay, it works exactly the same, except now it's giving me a tuple instead of a list. Okay, so notice that these square brackets change to round brackets, and so it's giving me a tuple instead of a list. So lists and tuples, in these respects, they are fairly similar. In fact, these kind of things work with many iterables. So I can even just take the range, I think, range 10, and ask for the fourth element. I'm not sure if this will work, but yeah, it seems to work. And I could take range 100, and I could ask for 99, 0, -1. Oops, that didn't work. Range indices must be integers or slices, not tuple. Okay, so what was the thing? Anyway, so yeah. Oops. Yeah, I'm getting a bit confused here. Maybe, yeah, so let's try this 5. Yeah, maybe I should put colon. Yeah, that seems to work. But now this Python has been too clever, and instead of giving me a list, it has given me another range. It has figured out that if I take this range and do this, then I'll get another thing which is a range. So it's refusing. It's really deliberately being quite lazy, and it's not evaluating. It's refusing to evaluate things. So it's very clever and lazy. So here again, it's just transforming ranges. Quite interesting. All this leads to very fast, because you don't actually, especially when you have large ranges, it doesn't have to evaluate them out fully. It just transforms the ranges themselves. Usually you don't need to worry about what is happening. As long as your code is correct, it will run. Okay, so that's so much about tuples and lists and so on. Any more questions?
So okay, even in WhatsApp, in webex chat we
Uh,
have some. So here Slim is asking that can we construct a matrix from tuples?
oh, looks like I'm looking at the old one. Okay, so can we construct a matrix from tuples? Well, let's try.
Okay.
So matrix, and let's try putting tuples here. 1 2 1 1 2 comma 2 3.
I think it is doable. Yeah. No.
There you go. So you can in fact construct a matrix from any iterable. So you can, for example, say matrix. This is I see in a lot of examples. A 2 by 2 matrix, range 4. So it constructs a 2 by 2 matrix using 0 1 2 3.
Okay. So one more question. How to integrate SageMath to Bash? Sorry, I don't know.
Maybe so what do you mean? You can run something. You can run Sage. You can do this with Python also. It's very so once you've installed Sage on your computer, you can type Sage and file name, and it will run that Sage file. So you can type that into Bash, and so you can create commands in Bash which use Sage, if that's the question you're asking.
Okay. So one more question. Are the elements of tuple immutable?
The elements, that depends. So you can have a tuple where the elements are lists and then they will be mutable, but the tuple itself is not mutable. You see the difference in what I'm saying here. The tuple is not mutable. The elements of tuple, whether they are mutable or not, depends on what they are. So
Okay. And in this webex chat, we have couple of questions. That first is, in a 3D plot, can we get X, Y, Y, Z, and ZX XZ projections? So basically, can we project those 3 plots onto planes?
okay, I don't know exactly. Maybe you can try saying looking at. Maybe I go back to the previous lecture and see. So where's our 3D plot? So here's this thing. Let's call it P, and oops. Okay, I have to run everything. So F. Okay, and now let's see P dot. What are the methods? Uh, I don't see any projection method, so I'm not sure. But there is some transformations you can do. Um, Transform group object. So you can do transformations. Probably you can use that or something. But those transformations are already happening in the JavaScript thing. So when I do this, so yeah,
Okay.
yes,
Can we move to next question?
yeah.
So Neha Malik is asking, when using L append 4, it adds 4 to the list 2 times. When you
No,
run this.
no, I did it twice.
Add
That's why
only,
it added it.
yeah.
So
What if you want to just once? I think,
I
yeah,
ran it twice. So
yeah,
I said m equals L append 4. First I said L append 4, so it added 4 to the list. Then I said m equals L append 4, then again it added 4 to the list, and it didn't do any. M is nothing still.
yeah.
So no, it only adds it once.
Hmm.
You can also sum add lists and add tuples. So L plus L will give you a list. Oops, this is 2 times 1 to
Uh,
99. So
what if
maybe
you want to add something just once and keep it that way, irrespective of times we run the command? No, but if we'll run
why
command,
would you run the command if you want to keep it that way? Don't
yeah,
run the command. That's all I can say. Okay. So don't run the command. If you run a command, things will happen. That's the agreement. Okay, and let's see, any more questions on YouTube? Are there
Somebody
elements
is
of tuple?
suggesting
Yeah.
for intersecting two surfaces. Probably
Yeah,
this is answer to the question that of projections, right?
right, right. So maybe that will work. But again, this is more about plotting. It's not so much about. So you have to manipulate the surfaces themselves. I'm not sure how that works.
One more interesting question on YouTube. Alina is asking that is there a way to sort list elements in descending order?
Yes, there is. So let's start with some list. L equals 3, 1, 2, and then sorted L, I think. So now I think there is something called reverse equals true. So you look at the documentation for sorted. So there's also a key. You can use a key. So for example, I could say key equals, I should really explain this, lambda x goes to minus x. So, okay, so let me explain this lambda. Okay, so now I've already explained function, so I can explain lambda to you. So there's, so we had this thing def double x, and then we said return. I'm breaking my own cardinal rule and not putting a doc string here, but this is just for demo. So this defines a function double. So now if you ask what is double, it says it is a function, and it works. Okay, double of 2 is 4. Now equivalent to this is this thing, double equal to lambda x 2 into x. Now if I type double, so just to convince you, okay, so maybe I'll call this double 1 to convince you that there's no confusion between these things. And let's call this double 2. Okay, so now if I ask what is double 2, it says again it's a function, but it says it's a lambda type function. So this lambda is something that came up in logic. There's something called lambda calculus. So this format lambda x colon something else, what it means is it represents a function which takes input x and gives output 2x. Okay, and so what it is saying is that double 2 is the function which takes x and gives output 2x. So it's equivalent to this thing that def double 1x return 2x. So it's the same as this, but it's an inline thing. This would be the same as saying, so I could do this in another way. So this same thing which I've done here, I could do in 2 lines. I could say def f x minus x, return minus x. And then I could say sorted L reverse equals true, key equals f. So this key means it will evaluate that function, and based on the values of that function, it will sort. And it gives the same answer. So these two are equivalent, and this so key equals f. So instead of having to do this in 3 lines, I can write this code once. So if you're defining a function just to pass as an argument to another function, this lambda construction is very helpful. Okay, so do you understand this lambda construction? It's just a way of defining a function without using the def. So okay. Hope that this is clear. You can use any other key. If you have a list of names, for example, you can sort them by last letter. Your key would be lambda, name goes to name. So this, yeah, actually strings are also iterables. So if I say S is Amri and I say S minus 1, then it will give the last letter of Amri. If I say S 0, 3, 0. Let's try with slightly longer string. 0, 5, 2. Then it will give those letters. Start with 0, jump by 2 till you get to 5. So strings are also iterables. Okay, so strings are iterables. Tuples are iterables. Then there are these weird kind of iterables which are not expanded at all, right? Like range. We'll talk more about them in a bit, and so on. Okay, so these are all iterables, and the main point of iterables is that we use them for looping. So let's talk about loops in Python. So so here's a simple example of a loop for I in range 10. Then again, as usual, the scope of the loop is indented 4 spaces. So this will just print I. So this is a very simple example of a loop. In place of this range 10, you can have any iterable. So here I could put uh, S, and it will print the letters of my name. Okay, so you can use here any iterable, and so in Python, so in most in other languages you would use a counter to loop. In Python, it's very easy to loop. Unless you really care about counting things, you don't use a counter. You loop over the thing that you want to iterate. So if you want to, for example, we could have G equals. So here, this I'll talk about more later. Symmetric group of order 3. Of the group G, and it prints the order of it. So this looks very magical, right? So you don't have to create a loop where you go over there. So somehow this group, symmetric group, the way it's constructed in Sage, it is already iterable in the sense it has an so for example, you can type list of G and give you a list of all the elements. If you type G, though, it won't give you a list of all elements. It will just say this is the symmetric group of order 3 factorial as a permutation group. This is actually when it says as a permutation group, it's going to be using gap. So loops in Python, avoid using counters, loop directly over whatever it is you want to work with. That's one thing that people who have programmed in other languages but not in Python would find. Um, okay, and you can also loop over other weird things. So here's an example I had prepared in advance. So let's. So here I've created a tuple which has 3 elements. Each element of the tuple itself is a tuple with 2 elements. And so this tuple, the first element of this tuple is 2 comma Amar, the second one is 4 comma Akbar, and the third is 5 comma Anthony. And so now you can loop over. So this tuple is called students, and so for S in students, print roll number dash is dash dot format. Okay, so here I have to explain this star S. But S, so this string uh, requires 2 inputs because it has 2 of these braces. And so I need to provide it 2 things. So I want to provide it. So in this case, I would want to provide the first thing to be 2 and the second thing to be Amar. But if I put S here, it will give an error because it will think of it as one input, which is the tuple. I wanted to think of 2 inputs. So this star just unwraps the tuple. So if I say S, then it's the tuple. If I say, I don't know if this works, star S, I can't use star expression. Yeah, anyway, but when you, it will think of it as 2 elements in the input. So anyway, so here again, we are not looping over a counter, we are looping over an iterable itself. So yeah, so that's an example. And iterables can be infinite. So for example, there's something called primes in Sage. So so let's try to use this. So so let's try to define a function which will find the number of primes which are at most n. Okay, so return the number of primes at most n. And so one way to do it is to say, okay, we'll start with count, we will count them. So we'll say output equals 0. And then we will say for x in P, if x is greater than n, then so I notice my cascading indentations. Then you stop and return the count that you have got so far. Else, I guess you add one output. And to add something to a thing, you would use this thing plus equal to 1. Okay, so I have defined this function npn. Let's see how it works. For 20 print np. Oops, this is Python 2, Python 3. So it's printed the number of primes less than or equal to n for each n between. So if you want, you can make this a little easier to understand. Say print n comma npn. So number of primes less than or equal to 10 is 4. The number of primes less than or equal to 19 is 8. So here this prime is an iterable which is infinite, but I have made sure in my program that this will stop at some point. Otherwise, it will just keep running without stopping, and you'll have to kill it. So that's so sometimes it's useful to have iterables which are infinite, provided that you make sure that your algorithm will stop. Of course, sometimes you won't know if it stops or not. So these are undecidable problems. Okay, so iterables can be infinite. And sometimes you need the counter. So let's just see. I'll just change this a little bit. So what I'll do is, instead of keeping the output, I'll change it. So there's something called enumerate. So let's see what is L right now. L is 312, and I'll say enumerate L. Okay, so it will say enumerate object, which is not very helpful. So to understand what it is, let's say list enumerate L. Now this is a list of tuples where this 312, the second coordinates, these are the elements of L, and it has added to the beginning 0, 1, and 2. So it's keeping track of which index these elements are. So it's giving index comma element. So index 0 element at index 0. So this is the same as saying I comma li. So this is a, so here we could have used this. So for example, instead of doing this, we could have said for I comma x in enumerate P. So here notice that I'm looping. This is a very interesting thing. You can loop over a pair. This pair is going to be in enumerate P. So and so then if x is greater than n, just return I plus 1, I guess. It will tell you how many primes I have gone through. And that's it. I don't need any of this. And it works. Oh, maybe there's a shift or something. Maybe I should say return I itself. Yeah. So this is exactly the same as the previous program, where I shortened it considerably by using enumerate. So yeah, let's see. And what else do I want to talk about? Python has while loops. But okay, first let's pause for questions again, because I think I covered quite a few things. Maybe a little confused. So suppose roll number and name already written in Excel file. Yeah. So you can use this. I'll talk about, okay, I don't know what Excel, but I'll talk about reading files and so on. Maybe in the, yeah, I'll talk about reading files. A great question from Satya Bagchi. And any other questions? Let's see on YouTube. Uh, Yeah, Irfan Habib asks, once you have used the command reverse, then what is the necessity of the function f for getting? Yeah, of course, there's no necessity. I was just using that as an example, but you may want to sort a list of strings by in increasing order of that last letter, in which case you would use the function lambda x goes to x box minus 1, which will pick out the last letter. So the key is, can be any function. It doesn't have to be minus x or whatever. So it's just illustrating the key. And yeah, so let's see a little bit. If I have, yeah. So let me show you how to load text files and so on as iterables. So so I have here in my let's show you picture 2. Oops, that's what I meant to do. I have this file called pop.csv. So this is a file which has a list of cities, their latitudes, their longitudes, the country. What is this ISO2? That's the 2-letter name for the country. Admin name, this is yeah, anyway, so there's a whole bunch of things. And so the thing to note is that the first entry is the city name, and the second last entry is the population. And then there's something called population proper. So this is the population of the metropolitan area, and this is the population of the limits of the city proper. And so here for Delhi, for example, it is, oh my God, 29 million. And for the city proper, it is. So we have some data like this, and you would like to, analyze this data, play with it, and so on. So it's very important to be able to read data. So if you have an Excel spreadsheet, you can probably export it to CSV, but I think there may be also be a Python library for Excel to read Excels. But here, since I'm not too fond of Excel, I'm just going to work with the CSV file. So you can work with any text file. Okay, so let's go back here, and I will show you how to do this. So firstly, let's read this file. Okay, so I will open this file. So firstly, I will give it a name. So I'll say POPL equals, and then I will say open. And then first argument you give is the file name pop.csv. So you have to look up the documentation for all the gory details here. But the two basic things are what type of how do you want to read, how are you opening the file? Are you opening it for reading or writing or appending? So here I'm going to open it for reading, so I'll put R. And there's one more option I needed to put here, new line equals. So in this file here, if you see, okay, if you open it in using some raw editor like Emacs or Notepad, you will see that these are, they're actually \n's are the new lines in this, the way this file is created. So I needed to add that, and so I do this. So now I have opened this file, and if you ask what is population, it's some something, okay, but it turns out that I can actually read the lines. So if it were so since it's a CSV file, I need some more utilities. There's a so that brings me to another thing. When you need to use various non-default libraries, you need to import them. So there's a library called CSV for importing CSV files. So I'll import CSV. You can look at what this is. This module provides classes that assist in the reading and writing of CSV files and implements the interface command described by PEP 305. Although many CSV files are simple to parse, blah blah blah. So there's various, you know. Oh yeah, so there's also Excel, I guess. So you can, you know, go through the documentation here. Let me just show you one possible thing. So now, so I'll just create. So I'll create an iterable from this file. It's called file reader equals, let's say, popl. This is provided by that. So the CSV. Let's see what CSV. So now I've imported this module called CSV. So all its commands will be given as um, CSV dot whatever. So let's see. So there are so there's CSV reader, and this is the command that I want. So you know I googled around and looked for the documentation and figured this out. So CSV reader, and then okay. So this is now we ask what is file reader. It will probably just say it is CSV reader object, but I think this is an iterable. It has an it is an iterable. You can loop over and things like that. So what this iterable will be, each see, normally if you had a CSV file, so when you read a file in Python, each line becomes it becomes an iterable, and each line is an entry of that iterable. So it iterates over the lines of the file. But now we have a CSV file, you'd have to parse each line, which would be a string, but we don't want it to be, you know, we want to parse it. So all that headache is taken care of by this CSV dot reader population. Now I can just show you something for line in file reader, print uh, line 0. So let's just do this, print line. So what it's doing is it is showing you what it has, this file reader has given. So in place of each line, it has given me a list, and the entries of that list are the various entries in that line, each one given as a string. Okay, so now maybe I want only the 0th one, and which is the name of the city, and maybe the last one, which is the population proper, or maybe I want the population of the metropolitan area. So let's try this. -1 is the last one, -2 is the second last one. Okay, nothing happened here, but this is because this thing was what is called a generator. It's already been used up. I need to refresh it. So let me just uh, do this again. I need to run it again. Okay, I need to run it from here. Okay, so and now you see it has given me a list of all the cities. Oh, oops. I hope you can see this. It's given me this list of cities along with their populations. If I just wanted to store these things, then I could say L equals. Now there's another way of looping, which is sort of inside a list. So I need to load this again. So once it goes through it just forgets what is there. So I need to open it again. So it's a good practice to close after you're done with reading it. So here I would say, let's close population. Okay, so now it's closed the file. Now let's open it again and then let's also do the file reader business again. And now I want to create a list with just these two entries. So what I'll do is L is equal to, and I'll give you a list. I want line ka 0 and line ka -2 for line in file reader. So this is another way of looping in Python. So instead of saying for line in line reader, you just create a new iterable from an old iterable by saying like this. So let me just show you what happens. So if you ask what is L now, L is a list whose entries are the first and second last entries of the lines in the file. Okay, and I can also so now I can look for L5, for example, and I get Chennai has a population of the metropolitan area has a population of 11,324,000 people. So that's one way of dealing with files. So usually each file format that you have, you'll have to do a little figuring out of what is the best way to load it. There are lots of libraries available for various kinds of things. There are various standard formats for files. So the CSV library, I think, will also help you with Excel. So you know, you'll have to just. So let's see, what else do I want to talk about here? Yeah, so I also want to talk about dictionaries, another very useful way of storing information. So a dictionary, what is a dictionary, right? So it has words and their meanings. So those words are what are called keys, and their meanings are. So let's just pick a couple of cities here. So I'll take Shiliguri. Anybody from Shiliguri here? Uh, so this is the basic format for defining a dictionary. You put everything in curly brackets. The key is written, then there's a colon, and then there's a value. So what is the population of Siliguri? I lost it. What order is this actually? Probably in decreasing order of population. So yeah, there it is. 294546. Very accurate. And let's add one more. Let's add Tirupati. So this is a dictionary whose keys are strings and whose values are just integers. And so I can type D of Siliguri. It in fact gives me tab completion, and it will give me the population of Siliguri. Okay, so this is a bit laborious. What we could do is we could in fact we have this L, right? So we could use this L to create a dictionary. So when you give, so there's firstly there's this dict, there's this dict function for creating dictionary. So you don't always have to use the curly brackets thing. And if I say dict L, it will create a dictionary whose keys are the city names and uh, whose values are the populations. Unfortunately, they are still strings. So maybe I should create another one. M equals, let's say, L0, comma, eval. So it will evaluate the string. L0, comma, eval, L1 for L in. Oops, that didn't work. Maybe. Oh yeah, so I don't want the first entry. So L1 colon, because the first entry, that is not a number. It says your population. The city population, so that came in, cannot be evaluated. So that's, now what happened? Eval L1 or L in L1 colon. Okay. Then,
Sir, L caps.
no, for little l in L caps. So that's okay.
Okay, okay.
So, okay, nah, never mind. I'll figure it out later. So, I wonder if this works. Yeah, that seems to work. No, that also doesn't. Same error. Invalid literal for int with base 10. Oh, okay. So that doesn't work. So something is happening anyway. So here, but okay. Let me just turn this into a dictionary. So I have this L. I'll just say dict M. Something is wrong here. None M is not there. Dict L. It turns this L into a dictionary. So now I can take this. Let's call this dictionary D. And now I have, like, I can look up in this dictionary. I can look up different cities. So let's look at cities starting with BH. So I have Bhagalpur, Bhavnagar, Bhubaneswar, Bhopal. So let's see what is the population of Bhagalpur, and there you go. I get it as a string, not as an integer. So I need to convert it to a string. Need to figure out how to do that. So wonder what's happening there. So let's type L1 colon. Maybe some other entry is messed up. There's, oh yeah, some entries are missing and so on. So there may be some issues there. See, I think, if I remember correctly, there were a couple of, the file itself may have some, here for example, the Panchkula and Kagaz Nagar, wherever that is, they are empty. So maybe if I try L1 colon up to -2, then that will remove those two last ones. And now if I type, so let's try that. Oh, I deleted that. So M equals, anyway, this kind of thing is always a bit of a headache for L0 comma L1 for L in L, starting with the first and going up to -2. Let's see if this works. Yes, that has worked. And now I do dict m, and it okay, but I forgot to say eval. Yeah, and now I say dict m, and yeah, I got what I wanted. So now I have the dictionary with the keys being the city names and the values being m, the population. And you can iterate over the keys of a dictionary. So here I can do sum of. So you can do the sum of a list, for example. So remember, L was my list. Okay, so now I want, suppose I want only the populations, then let me do it like this. So sum equals 0 for city in D in oh, okay, maybe I should have. So I still have D here. Okay, let's go to the next window down. So for city in D, so if you iterate over a dictionary, it will actually iterate over the keys of the dictionary. So this will iterate over all the keys of the dictionary. And then let's try to compute the total population of these cities. And then let's print this out. Maybe I shouldn't call it sum because sum is already built-in command in Python. It's to sum over a list. S plus equals this. What is the problem? Integering and class string. Okay. Somewhere here I have a string in the thing. Oh, I still have this. Why is it still there? Oh, it's the old one. So let's do this. Dict m. Okay, there you go. So now it's added up the populations of all these cities, and so I can manipulate, over dictionaries as well. There's another way to do this. I type sum, and then I create a tuple, which is just d city for city in this what uh, I defined sum. Ah man, I messed up. Okay, let me just restart the kernel. So sum is a predefined thing. Okay, I need to. Okay, but now I'm pretty much. I'll have to run all these again. Maybe I'll do this. Let me explain this. So L equals 312 32 312. D equals dict enumerate. So now what is this dictionary? The key 0 has value 3, the key 1 has value 2, and the key 2 has value 1. And now I can do sum of L. This gives me the sum of all the entries of L. I can also do, just for illustration, this is not usually needed, D of K for K in D dot keys. If I only had the dictionary and didn't have the list, then I could do this. Or K in D is actually just K in D. And that also works. So you can sum over all the values of the dictionary. Okay, maybe it's time to stop. There's quite a lot of material covered here. I'll share with you a slightly cleaned up version of this worksheet so that you can. But remember, finally, it's you have to kind of look up things and figure them out yourselves. I can only show you small percentage of the things that are available in Sage or in Python. And again, my own experience may be limited to the things I do, so I have missed out a lot of interesting things. So let's see if there are more questions. We have a few minutes to take questions. How is eval changed from string to int? Yeah, so this eval is basically tries to evaluate a string. Let me show you this eval. It's very useful. So if I take eval and put a string 10, it gives me an integer. If I take eval and instead of that I put a string which is a tuple. So if I put 2, 1, 3, 2, 1, now this is a string, but it takes the string and tries to evaluate it. So basically it does whatever Python does when you type something into Python. It tries to evaluate it. So eval is very useful for parsing files. If you've stored, you might not want to store your data in an SOBJ file like I showed you last time, because then it's not human readable. So you might want to store your data in as a text file. So for example, you could open for writing. Okay, example.txt for writing, and then you could say f dot write f. Okay, open, I guess, not file. And now f is open for writing. F dot write hello, and then I will put one more f. What is that? F dot write by. Okay, I don't know what these outputs it's giving. I think it's giving me the length of the string. But ignore that. And now let's go look at what this file looks like. So I have got this file example.txt here, and oh, I have to close it also. So f dot close. Until you close it, you're not sure what has happened. So it's got hello and bye. You might want to put each thing on a new line. So then what you could do is you could put \n. But here I'm just writing strings, but you may want to write down the output of some calculation you did. And in that case, those would be, when you read it back, you may just want to evaluate it. So that's why eval is very useful. I have to close. Now, if you look at this, it's got hello and bye on two separate files. But those could be outputs of your calculations. So yeah, that's one. Eval is very useful. Any more questions? So eval will change it to whatever it, Python will read it as a string as.
This like open example.txt that will create the file first, then we are writing on it.
Yeah. There's another one where you can say A, so then it will only append to that file.
Okay, so that existing file we use a.
Yeah. So now I write something new here. And then if I go back to the file, it would have. I have to close it, of course.
Close it again.
Yeah. And then if I go back to the file, it will have added. So yeah, so you don't have to lose your information. Be careful. You can easily overwrite your file if you use W instead of A.
Okay, thank you.
Yeah. So yeah, often I use text files to write my calculations because then I can show them to others, look at them by. Whereas SOBJ files, you don't know what's happening.
Okay. So there is one more question. What are the different formats to save files most preferable?
There are many formats, so as depending on the content. So I actually usually just use text files with commas separating the entries, which is basically CSV. But if you just want to store something and load it, without parsing and so on, SOBJ files are fine. I don't know if there's a clear answer to that question. There are lots of libraries for different kinds of files, dealing with different kinds of files. If you have a group, then how do you want to save it? Best thing is to save it as an SOBJ file, uh, because then the next time you start your session, you can read it. But then maybe you can save it. There's some text way to construct a group or something. So it depends on the situation very much what you want to do.
Then our Venkatesh wants to know that different type of errors that we often make and how to find and rectify them.
Oh yeah, so that's a whole thing in itself. So the errors are actually called exceptions in Python. So there are index. You've already come across a few, right? We've seen type error, we've seen index error, and so on. So if you Google Python exceptions, you will see the different types of. So the exceptions themselves, they are. We'll talk about classes next time. They are classes, and they form a tree, and each type of error would have special cases, which are another type of error, and so on. And yeah, it's a bit involved. I can't really explain it so quickly. I'll have to.
Amri, maybe what Venkatesh means is the errors
Yeah.
made by the beginners, like
Oh,
usual. Yeah.
those errors. Yeah, there was that book we used to have, Common English Errors of Indian Students. That kind of errors, yeah. I don't know. It
We
depends on the.
sometimes, yeah, this for example, like tuples are not mutable. That kind of
Yeah,
errors.
yeah. Yeah. What errors did I make? So I used to get confused with this mutable and immutable. Uh, don't remember what errors I used to make when I.
List values, if you keep changing the original list, will also change. For example, if it's a
Yeah.
list, then u equal to l. Then if you change u, then l will also change. That kind of mistakes we come
There
across
are some
usually.
errors which I have been making throughout, no, and I have to keep. Mostly that's typing things wrong, but yeah.
But Arun, I think these tutors can explain this in tutorials.
I think you should make your errors and then see how to
Yeah,
fix them.
learn to
That's
correct it.
all. Yeah, yeah,
No, no,
yeah,
I said you can explain later. That's what I said. But good
Yeah,
to
fine,
know.
yeah,
Venkatesh.
Yeah.
yeah. Yeah, there are some common pitfalls, and if you don't know what's happening, then you can really, waste a lot of time trying to correct them. So it's good to have somebody. Sometimes you can just ask. Um, yeah. But now there are all these stack exchange sites and so on, and it's pretty easy to find solutions for most of these issues.
Yes.
Okay, then. Thanks for the lecture.
Very
Thank you, my pleasure.
Yeah.
thanks for this. So everyone, we will meet tomorrow at 10 a.m.
Oh, by the way, today's assignment is just to make your tic-tac-toe game. Let me just say one or two things. So this is
Yes,
completely open-ended. Is that today's assignment?
yes,
Yeah.
yes.
So it's
Correct.
completely open-ended. It's up to you how good you want to make it, whether you want it to check who has won, whether you want it to display very nicely or just some basic display, whether you want to use a list or a matrix or a dictionary, that's also up to you. So it's just an activity to force you to uh, come to terms with the concepts that I've been teaching. So just try to make a tic-tac-toe game. You can have inputs from player one, from player two. You'll need to use if, then, else. Oh, did I take? Yeah, if else kind of construction and so on. Okay, so have fun with that.
Yeah, I would also like to announce that I have shared 5 links for joining tutorials to you. So you can join any one of them if you want to. The tutorial will start at 3 p.m. today. Okay. So you can join any 5 tutorial rooms and just try your assignment. There will be a person to help you if you get stuck somewhere.
Yeah,
Okay.
better try before you go to the tutorial,
Yes, yes.
and then you'll know what you're getting stuck with.
Okay.
So
So
each room will have different tutors or what?
yeah, yes, each room will have different tutors.
So if you go
Okay.
to a room and find it too crowded and the tutor is busy, you can go to another room.
Okay.
Okay. Okay, then thank you, Amrit sir, for this nice lecture. So shall we end this talk now?
Yep, see you tomorrow.
Tomorrow, bye. I'm going to.